In this video, we're going to go through the review for exam 2. Let's start with question number 1. Portland's population in 2007 was about 568,000. It's been growing by about 1.1% per year. Write a recursive formula for the population of Portland. So if you watched my prior video, I talked about if it says recursive, that you want to look for a p sub n minus 1 in your formula. So you'll go to the back page of your test and look for the recursive formula. Now, we also need to know if I'm going to be using a linear or a exponential equation. Your key on this problem is you were given a growth rate of 1.1%. If it's ever a percent, then that means we're going to use an exponential model. So I'm going to go to the back of my formulas and look for the exponential recursive formula. I suggest when you get the test, you label your formulas so that you remember which ones are which. So the recursive exponential formula is going to be p sub n equals p sub n minus 1 multiplied by the quantity 1 plus r. Now the only thing I need to do is plug in my knowns. Well, the 568,000 is the initial population, and the 1.1% is my rate, which I'm going to write as 0.011 when I write it as a decimal to plug into my formula. Since my recursive formula doesn't involve the initial population, all I need to do is replace r with the rate. So my formula is going to be the population at any point in time is equal to the population last year, which is my n minus 1, that's what that means, times by 1 plus 0.011. And of course, you can go ahead and add the 1 to the 1.1%, giving me p sub n equals p sub n minus 1 times 1.011. Next, let's change it to the explicit formula. Again, if you watched my last video, I talk about the explicit formula is going to always have a p sub 0, a starting amount, as well as an n. Looking back on my sheet, I'll be able to see that the explicit formula for an exponential model is p sub n equals p sub 0 times by 1 plus r to the power of n. But we are going to replace p sub 0 with my known, and r we also know. Therefore, my formula is going to be the population at any point in time is equal to 568,000, which you may want to just add your 3 zeros so you don't have to worry about the word thousand, times by 1.011, which is 1 plus r to the n. Now, sometimes I see students want to replace that n, which we can do if I tell you about or ask you what is the population at any point in time. But when I ask you for a formula, that means that I want to see or keep my n an unknown so that it's a formula I can plug into later. Let's move on to part C. If this trend continues, what will Portland's population be in 2018? So since I started with a population back in 2007, I'm going to subtract the 2007 from 2018 to find out that my n, or the time that has passed, is 11 years. Once I know what n is, then I want to plug it into my explicit formula. Plugging it into the recursive won't be helpful because I would need to know the population 1 year earlier, not 11 years earlier. So I'm going to write p sub 11, so 11 years after the initial population, is going to be equal to 568,000 times by 1.011 to the power of 11. Let's type it into our calculator. 568,000 times by, now here's where your calculator, you'll want to use parentheses, otherwise you should normally do your power first. So if you have a little more robust calculator, you can put in parentheses 1.011, close my parentheses, to the power of, which is my xy, and then 11. Hit enter, and let's try that again. Let's take 568,000 times by, use my parentheses, 1.011, close my parentheses, and then take that to the power of 11. If you do not have parentheses in your calculator, you'll need to do 1.011 to the power of 11 first, and then multiply it by 568,000 using your order of operations. This gives me an answer, which I should probably round to 640,646. Notice that I'm going to round to the nearest whole number. Now, whether you choose to round up to 6 or keep it 5, I will tell you how to do that on the test. And if I don't, use your logic there. Using rounding rules would round it up to 6. But if you wanted to think about a 0.5 of a person wouldn't be considered a person and round it down, that's fine too. Let's go ahead and move on to part D. When will Portland's population reach 1 million? So again, I'm going to use the explicit formula, except for 1 million is the population, not N. So I'm going to put 1 million on my left-hand side equals 568,000 times by 1.011 to the N. Don't use 11 there because now we have a different amount time or year that we're trying to find. Next, to solve for N, we need to first divide by 568,000. 1 million divided 568,000 is equal to 1.76056. We're going to keep that in our calculator. Next, in order to isolate N, if N is your power or your variable is your power, you need to take the log of both sides of your equation in order to change this to a multiplication problem. So I get the log of 1.76056 yada 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 equals log of 1.011, but now it's multiplied by N. So to isolate N, to undo the multiply, we're going to divide. So I'm going to take the log of 1.011 under the log of 1.76. To do this in my calculator, I already have the 1.76 repeated in my calculator. So I need to find the log of that and divide it by, and for me, I need to put in 1.011 first, hit log in my calculator, and then hit equal. So N is approximately 51.7035, or since this is a year, I'm probably just going to round it to 51 or in the 51st year, and add that to my 2007, my initial year, to figure out what actual year the population will become 1 million. So in the year 2058. Let's move on to question 2. A population of beetles are growing according to a linear, so they actually tell you in this case that it's linear, growth model. The initial population at week 0 is p sub 0 equals 7, and the population after 7 weeks is p sub 5 equals 67. Round answers to the nearest whole. So what's the common difference? So when we think about that word difference, we want to think about subtracting, typically. How many beetles do we have now compared to before? So if I subtracted 67 minus 7, I'm going to say there's 60 more beetles. But the common difference isn't just the raw difference, it's the amount over time. And so since 5 weeks has passed since week 0, we're going to need to divide by 5 in order to get the difference per time period, or in this case, per week. So the difference is going to be 12. Once I know that, I can find the explicit formula. If you remember, the explicit formula requires me to know p sub 0 as well as d or r. So looking in the back of my sheet, I have p sub n equals p sub 0 plus d times n for the explicit linear model, but I'm going to replace p sub 0 with my starting amount, which is 7, plus d, which I found to be 12, times by n. Part C. After how many weeks will the beetle population reach 283? So since this is a population, I know that's p, and I'm trying to figure out the time or n. So I'm going to say p sub n, or replace the left-hand side with 283 equals 7 plus 12n. And now we just have a small equation to solve. Subtract my 7 to get 276 equals 12n. Now I'm going to go over to my calculator, take 276 divided by 12 to give me n equals 23. So after 23, and I want to make sure that I write my unit, it's 23 weeks later that we have a population of 283. Okay, let's move on to question 3. During the year 2015, Salt Lake Community College Parking issued 280 tickets. Every school year thereafter, the number of speeding tickets issued is predicted to grow by 6%. So I see 6% there, and I'm thinking exponential because it's a percent. So that's 0.06 when I change it, or 600ths to a decimal. If this trend continues, how many tickets are predicted in 2024? So this year. So let's subtract the 2015 from 2024. That gives me 9 years. So the time is equal to 9. But I need to write a formula in order to be able to solve this. Because I'm jumping in time, I'm going to use the explicit model. So p sub n equals p sub 0 times by 1 plus r to the n. I do know the initial amount is 280. I am trying to find the population, or the parking tickets, in 9 years. So I'm going to take 280 plus 1 plus 0.06, or 600ths, to the 9th year. If you didn't have a fancy calculator with parentheses, you might want to start with 1 plus 0.06, hit equal, take that to the power of 9, and then times that by 280 to give you the answer. So again, interpret this not just using what you get in your calculator, but thinking about it. The 0.05 tickets doesn't make much sense. So I'm going to say they will likely have, and again, this is an approximation anyway, approximately 473 tickets that they issue. Let's move on to question 4. Motor gasoline consumption in the US has been steadily increasing. Suppose consumption can be represented by a linear growth model. With the recursive rule, P sub n equals P sub n minus 1 plus 2.2. In 2020, Americans used about 1.23 billion gallons of gas per year. What would the 2.2 represent or mean in this recursive equation? In this case, because we are talking about billions of gallons, the 2.2 is positive, so that means we're increasing our usage by 2.2. It wouldn't make sense to say 2.2 gallons. I'm going to guess it's 2.2 billion gallons. And I'm going to assume this is also per year. Find P sub 1. Well, P sub 1 means that I am taking that 1 and replacing it for n. So if I wanted to find P sub 1, that means that I'm going to take P sub n minus 1 originally, so that's 1 minus 1, plus 2.2. Remember, recursive means that I needed to know the prior year or prior time period in order to figure out the next result or amount. So P sub 1 is based on 1 minus 1 or P sub 0. Since P sub 0 or the initial amount is 123 billion, then 1 year later it would be 1.23 plus 2.2, or we would say that that's equal to 125.2 billion gallons. To find P sub 2, we're going to need to know P sub 1 last time, plus, again, 2.2. So this is going to be equal to my P sub 1, which I found above, 125.2 plus 2.2, or now in year 2, it's going to be 127.4 billion. In part D, it wants us to change our explicit model to, our recursive model to an explicit model. So what I need to find is, remember, for an explicit, we need to know P sub 0 and we need to know D. And so P sub 0 is given to us already, 123. And D is actually the number that we are increasing by each time. So D is also given to us as 2.2. So now I'm going to take this information, look on your sheet on the back if you need to, and find that the explicit linear formula would be P sub n is equal to P sub 0, or 123, plus, what is it increasing by? 2.2 every year, so times it by the years, or n. And keep it an n, because again, I'm looking for a generic formula. In part E, it says use that formula to find the projected consumption in the year 2045. So again, that's a year, so it's related to n. So I'm going to subtract the initial year. To find out, I'm trying to jump 25 years in time. So the amount in year 25 is 123 plus 2.2 times by 25. Throw that in your calculator and you'll find that that's equal to 123 plus 55, which equals 178. And again, I would suggest you add your units there. That means that in the year 2045, we will be consuming 178 billion gallons of gasoline. Let's move on to question 5. A population of 60 deer are introduced into a wildlife sanctuary. It's estimated that the sanctuary can sustain up to 300 deer. Now, when you read something about sustain or cap or limit, any of those synonyms that mean we get carrying capacity or we have a limit to something, then that means that I am not dealing just with exponential. It means that I'm dealing with logistic. So my K is going to be 300. I'm starting with a population of 60, and given the constraints, the population would grow by, constraints, the population would grow by 80%. So that means my rate normally would be 0.80, but that's going to be impacted by the sustainability number. So I'm going to go to the back worksheet and look up the logistics formula. My equation didn't copy over very well, but in order to find P sub 1, I'm going to need to find on the right-hand side P sub n minus 1. Well, since n is 1, that's going to be 1 minus 1 or P sub 0. So again, it's recursive, so we find the prior year. Plus r times by 1 minus P sub 0 over K, and then multiply it by P sub 0. Now let's plug in our knowns. Since P sub 0 is 60, I'm going to put 60 in each of those P sub 0 locations. When I throw this into my calculator, I like to do my order of operations, start in my group first, or my parentheses. So I'm going to take 60 divided by 300, and I'm going to take 1 minus that answer. Now I'm going to multiply that by 0.8 to give me 0.64. For that middle section, that's also times by 60 and then added to 60. So let's times this answer by 60 and add it to 60. And we get P sub 1 is equal to 98.4, or again, rounding as requested to the nearest whole, we would say it's 94 deer. To find P sub 2, we're going to repeat this process, except for every P sub 0 is going to be replaced with P sub 1. So P sub 2 is going to be P sub 1 plus R times by 1 minus P sub 1 over K divided by P sub 1. Use the same rate and carrying capacity as we did before. Throw it into calculator and you will get approximately 150.78 or approximately 151. As mentioned before, you can either round up or down, and I would still give you the points. Okay, let's move on to number 6. The population of Colville, Utah is growing according to an exponential growth model. According to the census data in 2010, the population was 1,363, and in 2020 it was 1,644. Find the growth rate. Okay, so this one, I'm asking for a rate, so I'm thinking exponential. I am jumping in time, so I'm thinking explicit. So I'm going to go find that formula, which is P sub n equals P sub 0 times by 1 plus R to the n. And I'm going to start to fill this in with information that I know. So starting with P sub 0, that's the initial amount. I'm going to say, what was the initial population? Well, as far as I know, the initial population in 2010 was 1,363. Next, we were given the population in 2020, which would be a future population from the initial population, so 1,644. So that's P sub n. I don't know the rate. They didn't give me any percentage. In fact, that's what I'm trying to find. And then I need to find, n, by finding out how many years occurred between 2020 and 2010. So 10 years have passed, so that's my power. Let's go ahead and solve this equation. So to solve this equation, we're going to start by dividing by the 1363. When I do that in my calculator, I get a result of approximately 1.0616, yada, yada, yada. I'm going to change this. It's no longer equal, but approximately. And the 1363's reduce, leaving me 1 plus r to the 10th. In order to get rid of the power, now we don't have to use a log because I do know the power. So I can undo a power that's known by doing a root or using a root function. To do this, I use the 10th root because I want to get rid of the 10th power. So I'm going to take the 10th root of each side. Doing that in my calculator, I've got my 1.206 on my calculator already. I'm going to take that to the root of 10. Now, most calculators have this. Mine doesn't, but if you watch some of the videos, the other option is to take this to the 1/10th root power. So I'm going to go ahead and take this to the power of, and then in parentheses, I'm going to put 1 divided by 10 for 1/10 because I don't have fractions. Then I'm going to hit equal. And this gives me what is equal to 1 plus r because the powers reduce, whether you use a 10th root or a 1/10th power. At this point, we just have one more step. We want to solve for r, not 1 plus r. So I'm going to subtract the 1, leaving me 0.01892. But since I'm asking for a rate, we usually change this to a percent. So I'm going to say this is moving it 2 places or timesing by 100, 1.892%. And they asked me to round to the nearest tenth after I change it to a percent. So I'm going to say that's approximately 1.9%. So Colville, Utah, between those years was growing by approximately 1.9% per year. Okay, let's go ahead and start our finance section. With finance, it's usually all of the questions will be dealing with money, which means that we're going to be working on the right-hand side of our formulas on the back page. So let's say you deposit $2,000 in an account earning 7% interest compounded monthly. How much will you have in the account in 10 years? So to know which formula we're going to use, as mentioned in my prior video, if I only put money in one time, then I'm going to use my compound interest formula. If I put it in regularly, then I'm going to use my savings annuity. And in this case, I only put money in, and you've got to be careful, you deposit $2,000. It didn't say I deposit $2,000 a month, which would push it into a savings annuity. Since I only deposit $2,000, I'm going to use the compound interest formula. Now I just need to plug in the correct variables. So since the $2,000 is a deposit, that's my initial principal. I don't have a D in this formula anyway. So I'm going to say A, the amount in my account is going to be equal to 2,000 multiplied by 1 plus the rate of 7% or 7/100 as a decimal divided by N. Now N stands for, this is N different than growth models. N is how often does it occur? Does the interest, how often is the interest added to my account? So that would be 12 since it's monthly. And then I'm going to multiply it to the power of 12 times by T for time. And that's I'm keeping it in there 10 years. Throwing this into my calculator. Again, everyone's calculator is a little bit different. I've got a more basic calculator here. So I'm going to do one step at a time. I usually like to change my power to a whole number instead of having it a multiplication, because that's just a quick one to do right up front. Then I take 0.07 divided by 12, add my 1, take it to the power of 120, and then multiply it by 2,000. And that will tell me that the amount in my account after 10 years, I will round this to the nearest cent, even if it doesn't ask me to. Money always ends in cents, almost always. $4,019.32. How much interest will you earn? Part B. Well, since I deposited $2,000 and I now have $4,019.32, we just need to subtract off the initial deposit to give me the interest, which would be equal to $2,019.32. Okay, let's go ahead and move on to number 8. You can afford $400 per month for a car payment, and you found a 5-year loan at 5% interest. How big of a loan can you afford? So since this is a loan, what I want to look for is that means that the amount that I owe is going to go down each month. Okay, so if I buy a $20,000 car, the next month I shouldn't owe $20,000, otherwise they call it underwater or over your head. So I'm looking to decrease the amount I owe every month, which means I'm going to look for the formula with a negative exponent. Finding the third or bottom formula on your sheet, we're now just going to plug it in and do the math. Since I can afford $400 a month, that wouldn't make sense to plug it into P sub 0 because that's your initial loan amount. That's actually what I want to find. So I'm going to put P sub 0 equals 400 multiplied by 1 minus parenthesis 1 plus the rate. I've got a 5% rate every month. Okay, so that's going to be 12 for N minus 12 multiplied by how long is my loan, which is 5 years. All divided by 0.05 over 12. When you do this on a test, make sure you write the formula and also maybe show me some mid-steps if you don't punch it all into your formula at the same time. Once you punch that through your calculator, you'll get an answer of approximately, and again change this to money, $21,196.28. I will also mention if you get an answer which doesn't make sense, let's say I punched this in and it ended up being 176 point something, then you'd be like, hey, you know what? When I talk about buying a car, $176 and paying $400 a month for it makes no sense. So if you plug it in the wrong formula, you will often get an answer which doesn't make sense. So please do that extra check at the end and make sure your answer makes sense. And if it doesn't, go back and either check your math or check the formula that you used. Sometimes the hardest part of these questions are making sure that you have the right formula. So this next one is one that it's hard to know which formula to use because retirement is used for both the annuity formulas. So again, you want to ask yourself, is my retirement going down or going up? If it's going up, I'm going to use the positive exponent. And if it's going down, I'm going to use the formula with the negative exponent. So if I have $5,000 saved for retirement and your account earns 6% interest, how much will you be able to pull out each month? Pulling out indicates that I am using a negative exponent, or I'm dropping the amount of money I have in my account. It's not increasing, it is decreasing because I'm pulling it out. So that means I'm going to go over to my formula sheet and make sure I use the negative exponent. Let's go ahead and plug things in. 500,000, is that my initial amount or is it my withdraw amount? And in this case, 500,000 is how much I now have or the initial amount in my savings for retirement. So I'm going to put 500,000 on my left-hand side. I don't know how much I'm going to pull out each month. Open up my parenthesis, 1 minus 1 plus my rate of 6%. This is, I want to take out, withdrawals how often? That's going to be each month. So that's 12. Take that to the power of negative 12 times by t. How long do I want to take this money out for? In this case, I'm making the assumption of only 20 years. And divide it by the 0.06 over 12. Now, when you watch the videos on these problems, sometimes we'll do everything on that right-hand side and then divide 500,000 by that answer. Or you can, some instructors like to multiply both sides by this fraction in order to get rid of that complicated, complex, what we call a complex fraction. So you can do it either way, just do whichever way you feel comfortable. Let's go ahead and finish this out. If I multiply both sides by that fraction, I get 2,500 on the left, and D is multiplied by 0.6979. Dividing that, I end up with D is approximately $3,582.16. If I round it, it's 5.5, and so I need to round it in order to change it to the nearest cent. I want to look at that and make sure it makes sense. If I have $500,000 saved for retirement, and 3,582 seems a little bit low, but it might be correct. I am taking it out for 20 years and it is not a huge interest rate, so seems appropriate. Now let's look at the problem below it on question number 10. Again, with that $500,000 for retirement, this one is going to use a different formula because I want to have $500,000 in 20 years. So that means I'm going to be increasing how much I have in my account until I reach the $500,000. So I want to look for or use the equation with the positive exponent. Finding the correct formula with the positive exponent, I am now going to just plug in the appropriate numbers. So the 500,000, that is not my deposit per month, but it is the amount of money in N number of years. So that will be what I've got on my left-hand side. I want to find D. And I've got 1 plus my rate of 7%. And again, I'm putting it in every month. Typically it is 12 for N. The power is going to be 12 times by T. How many years? That's my 20 years. Minus 1. And divide that by 0.0712 over 12. Again, you can either multiply both sides by the 0.07 over 12 first, or you can calculate everything on the right-hand side first. I'm going to go ahead and just do everything on the right-hand side on this particular problem. I get approximately 520.9 on the right-hand side multiplied by D, and so I'm going to divide both sides by that answer. As I mentioned before, never retype in this number, but make sure you keep it in your calculator so that it is as accurate as possible. Small rounding errors here, even if you go out 3 places, may make a difference in the cents or even in the dollars long term. So I'm going to put D is approximately $959.83. So I've got to put in about $959 every month in order to have $500,000 if I plan on retiring on that amount in 20 years from now. Part B, how much total money will you put in the account? We're going to take our answer from A because that's actually the deposit. And I'm going to take that answer and multiply it by how many times did I add that to my account. So I did it every month or 12 times for 20 years. So I'm going to basically multiply that answer. And this is where you will want to clear out your calculator. Make sure that you have it with the cents. So 959.83 times by 12 and times up by 20, or you could just multiply it by 240. And I get an answer of $230,359.20. Even though you have a 0.2, you want to add the 0 for cents. And C, finding the interest, all we need to do is say, well, if I have 500,000 now, or at the end of 20 years, and I deposited the $230,359.20, how much of that 500,000 came from interest? And we get an answer of $269,640.80. Moving on to number 11. You have $4,500 on a credit card that charges 23% interest rate. If you want to pay off the credit card, okay, there's your clue. You're wanting to pay off the credit card, which means the amount on that card should go down, which means I'm looking for the formula with the negative exponent. How much will you need to pay each month to pay it off in the 5 years? Hopefully you can pay it off in earlier than 5 years, but if you did it in 5 years, how much would you need to pay? So P sub 0, is that 4,500 or is 4,500 the D? Well, D is the withdrawal amount or the monthly amount if we're talking about months. And so 4,500 is my initial amount. It's what I owe right now, 4,500. So that's going to be on the left-hand side. I don't know how much to pay monthly. That's what I am trying to find, is D. And then 1 minus the quantity 1 plus 0.23 over 12 to the power of negative. N is 12 and time is 5 years. All divided by 0.23 over 12. And by the way, this assumes that you are not increasing your credit card spending. So you freeze your credit card spending and you just continue to pay it down each month. Let's go ahead and do everything on the right-hand side and see what we get. I get approximately 35.4729 on my right-hand side. So I'm just going to divide the 4,500 by that number. And I get an answer of $126.86 when I round it. Again, thinking about that, does it make sense? Yeah, I have 5 years that I'm paying it off, and I'm not really making a high payment, so 5 years to pay off 4,500 sounds about right. How much total, part B, would you have paid to the bank? So again, D is my payment. So I'm going to take that answer, again, making sure that I've rounded it to the nearest cent and times it by, I paid that 12 times for 5 years. That gives me an answer of $7,611.60 that I paid to the bank. So obviously, I only had $4,500 that I owed, but I paid them a lot more than that. So I paid a significant amount in interest, which is why your interest rate is so high. And if I want to know the dollar amount that I paid in interest, just go ahead and subtract, leaving me $3,111.60 in interest, which is a lot of money. So hopefully you guys have learned, don't put the money on the credit card. Let's go ahead and jump to the last problem. Suppose you can afford a $1,260 mortgage payment and you've been approved for a 30-year loan at 3.5%, which is actually really low. And this was written during the times when we could get a lower interest rate. But let's say you could get an interest rate for 3.5% and you want to figure out how big of a loan can you afford. This is very similar to your finance project. Notice it is a loan. My principal, or the amount I owe to the bank, should go down each month. So I'm looking for the negative power. I'm going to put 12,600 in for D. And I want to know the initial amount of my principal, or in other words, the mortgage amount. So I'm going to put 1,260. 0.035. Make sure you're putting your 0 in there when it's less than 10%. Divided by 12 because it's monthly payments, to the negative 12 times 30, or you can just change that to 360 over 0.035 over 12. And that should give you a mortgage, or initial mortgage, of $260,595.68. How much total will you end up paying the lending company once you've paid off the loan? Well, my payments were going to be $1,260, and then I'm going to pay that 12 times a year for 30 years. Or $453,600 paid to the loan or lending company. And how much money is interest on that? Since I took out a loan for only $260, but I paid $453, the difference between those is your interest, or $193,004.32 is interest. I hope you found this video helpful. Let me know if you have any questions